Hello and welcome to the EMC Live Roundtable, HEMP and IEMI Threats. My name is Belinda Stashukevich. I'm the editor of Interference Technology, the creator of EMC Live. EMC Live is a brand new online 3-day event hosted by Interference Technology. Featuring practical information and topics, this event will include roundtables, webinars, and videos on everything EMC related, and there's no cost to attend. Join us for our other roundtables and webinars this week. This roundtable is moderated by Bill Radasky. Bill received his PhD in electrical engineering from the University of California at Santa Barbara in 1981. He's worked on high-power electromagnetic applications for more than 44 years. He's published more than 400 reports, papers, and articles dealing with electromagnetic environments, effects, and protection during his career. In recent years, he's worked extensively in performing assessments for critical infrastructures to the threats of HEMP, IEMI, and severe geomatic storms. Panelists included on this roundtable are George Baker, Emeritus Professor of Applied Sciences at James Madison University, Rafiq Stepanian, Vice President of Engineering at Astrodyne, and Michael Caruso, Director, Government and Specialty Business Development at ETS Lindgren. This roundtable will be interactive. You'll be able to ask questions, and we encourage you to participate. Take a look at your GoToWebinar navigation pane. If at any time you have a question, we ask you to fill out the type box and hit send. To make the screen minimize and maximize, click the arrow button. To raise your hand to ask a question or report an issue, click the hand icon. We'll discuss the topic for 30 minutes. And now Bill will begin the discussion.
Okay, thank you. Welcome everyone here to this roundtable. We will be discussing the high-altitude electromagnetic pulse, HEMP, and the intentional electromagnetic interference by electromagnetic weapons, IEMI. I have a few questions that we prepared, and I'd like to start with what are the characteristics and differences between HEMP and IEMI threats? George Baker, do you have a view on that?
Yes, thanks, Bill. The big difference between the HEMP, the EMP you get from high-altitude nuclear detonations, and IEMI from RF weapons is the area coverage. The area coverage from the nuclear EMP can be continental, and where the IEMI, RF weapons, will cover areas out to, depending upon the size of the weapon, you can get effects from meters out to tens of kilometers. So that you're talking at most maybe city-sized areas as opposed to continental-sized areas. The other differences worth noting are that the EMP is very broadband. It's an effect that goes from subhertz out to about a gigahertz in frequency content. The IEMI can either be broadband or narrowband, and you can tailor the RF weapon environments to the target of interest, where the EMP tends to be pretty similar from any nuclear weapon and very, very broadband.
Thank you, George. That was great. Any other panelists have any comments they'd like to add? Okay, if not, let's go on to the second related question. And how do these electromagnetic transients relate to more commonly known EM electromagnetic transients such as electrostatic discharge, lightning, and radar? And again, I'd like to ask George his view on that.
Well, again, the electrostatic discharge and lightning would be more localized effects. You're talking about discharges, in most cases at single locations with ESD, electrostatic discharge, actually within circuit boards. And lightning, you're getting discharges onto points, antennas, and parts of the system that are exposed outdoors. Radar is maybe less localized, and radar, I would say, has very similar characteristics to RF weapons. In fact, many of the RF weapons that are out there use parts that you might also find in radar systems.
Very good. Any other comments from the other panelists? I would just like to add one quick point regarding lightning, because it's often asked. lightning tends to be at lower frequencies than the worst portions of the HEMP and IEMI threats. So, and we'll deal with the issue of protection later, but it is a bit different, whereas the ESD and radar are in the higher frequency ranges, similar to, as George said, IEMI. Okay.
Also,
yes, George, please.
Yeah, the lightning and ESD tend to be conduction currents rather than displacement currents. You're actually getting directly. It's almost like a direct injected currents in systems as opposed to field exposures. Although with lightning, you do get localized, pretty strong fields right around near the strike. But the worst effects are caused by the current injection effect.
Great. Thank you very much, George. Let's go on to the next question. What parts of the critical infrastructures do you consider the most critical for HEMP and IEMI protection? And why don't we start this one off with Mike Caruso.
Yes, thank you very much, Bill. What we have been seeing is the critical infrastructure segments that are paying the most attention to the protection now would be the financial sector and the electric distribution sector. We are seeing a little bit from the healthcare sectors, but so from my experience anyway, I would say that the most critical at this point is the electric utility sector.
Okay, thank you, Mike. Rafiq, do you have anything you want to add there?
Yeah, I guess Mike didn't cover the military side of or just talked about power lines. Also, I believe that the military communication facilities are going to be, not probably, but they're going to be most vulnerable, and those are the infrastructures that need to be HEMP and HEMP devices put on, installed, and make sure that the military has communication systems going.
Okay, thank you. George, your view?
Yeah, it's interesting. I taught a course in critical infrastructure, and I had the students do a risk analysis, take all the infrastructures and multiply their criticality factor times their vulnerability factor, and we came up with a sort of a hierarchy, and the electric power grid came out on top as the highest risk, and then your long haul communication systems. So the two systems that actually have to have long lines turned out to be the highest risk in this exercise: power grid and then the long haul communications. And with the long haul communications, we have to add that the fiber optic systems are quite vulnerable. There's a mistaken idea that fiber optics are immune, but it's because they have these power conductors down the length of the lines. They're also very vulnerable, and that would include the submarine cables, intercontinental submarine cables. I also would mention with the communication the big data centers. We're putting more and more eggs in single baskets with these huge data centers that are out there.
Okay, very good. I would just like to add, based on the work for the high altitude EMP as part of the U.S. Congressional EMP Commission, they also looked at many of these different infrastructures, and while all of the infrastructures have some issues, they felt that the electric power system was the keystone, mainly because so many other infrastructures depend on power. Of course, communications is very critical for the power systems to recover, and there are many interdependencies also. But it is clear that there are many different aspects of the infrastructures that are very important. Okay, let us go to the next question. How do you design protection from the high altitude EMP and intentional EMI? And again, Mike, would you like to start that off?
Yes, thank you, Bill. The basic protection starts with a six-sided shielded enclosure. You're going to be looking at an enclosure that's constructed from ferrous material because you want to be able to address magnetic component as well as the electric and plane wave. In addition to that, the critical nature of the enclosures, you've got to pay very close attention to all points of entry, and that would be for communications, for electric power, for heating, ventilating, and cooling, for fire protection, for fresh water, for wastewater. So in some of these facilities that can get quite large, the entire protection system can get quite complicated. And at least we not forget that grounding of these facilities is absolutely critical. We need multi-point grounds that are able to carry.
Well, Mike, did we lose you?
I'm still here.
Yeah, okay.
Okay. So that's we are also looking at the protection of the electric power coming in, and they have to be dealt with filters that have arresting devices in them. Most of the time, it's metal oxide varistors.
Okay. Rafiq, would you like to add anything to that?
Oh yes, I just lost the landline, and I'm going to speak on my computer speaker. I don't know how clear it is. Otherwise, I have to call back.
Yes, I'm afraid you're echoing there.
Okay.
Okay. Well, we'll move on.
Okay, please do. Yes.
George, do you have any other comments about designing protection?
One point I'd make is that we need to treat all of the what I call breach type penetrations, where you have the shield, but the shield's going to have doors and pipes coming in, and those are normally protected using waveguide beyond cutoff type arrangements, and that would be important. And then the other thing I just came to mind is for the power grid, it's looks as if the best way to protect, at least for the late time, the slow pulse part of the EMP is blocking devices to keep the transformers from saturating and maybe burning out. So that would be important. And also, you would need for the electric power grid overvoltage protection for the E1, the fast pulse.
Yeah, that's great, George. Thank you for bringing up the late time part of the hemp. Just one comment that I'd like to make, and then maybe Mike and Rafiq will comment again. It seems to me that the types of techniques for protection, for the shielding and the point of entry protection for cables and so forth, is really not anything new. The EMC community has been doing this for decades. But the real issue is to understand the requirements of these protective elements to make sure they're designed to be compatible. Would you agree with that, Mike?
Yes, absolutely, Bill, and that's an excellent point. The EMC world has been dealing with shielding of various kinds and points of entry for a long time, as you pointed out. What I do find is that as we get out there and discuss protection against HEMP and IEMI, the specific nature of the threat and the protection needed gets to be a bit confusing for some folks.
Okay, thank you. Rafiq, are you back on? I guess not. Okay, why don't we move on to the next question. What is the role of existing lightning protection for protection from HEMP and IEMI? And again, George, would you mind taking this on?
Yeah, the major point here is that lightning protection does not suffice for EMP protection. It certainly can help, but we need to be careful. There's another misconception out there that lightning protection will, in some large measure, protect against EMP. That's not true. The big benefit from lightning protection is if you have good lightning grounding, multi-point grounding for the buildings. That is a huge benefit for EMP as well, for diverting the EMP transients away from sensitive equipment to the ground. The other point I'd make is there were tests at Oak Ridge National Lab of distribution transformers, and they found, they tested something around 20 transformers, and they found that transformers that had inherent lightning protection right on the terminals tended to be immune from the fast EMP pulses, so that there's a good reason to believe that if you have these are MOV devices on your transformers, that may help protect against EMP overvoltages. But in general, those are not sufficient because EMP is much faster, has much faster rise time, nanoseconds versus microseconds, much faster rise time than lightning.
Yeah, one comment I'd like to make is there's a misunderstanding with a lot of people about what lightning protection means. Almost never is lightning protection adequate for a direct strike to your facility. The lightning protection that works is for lightning that is a bit further away. And so the idea that people are building lightning protection to handle 200,000 amperes hitting their house or the building is not the case. There will be some damage. So not even the lightning protectors can handle that. But the point is, as George has mentioned, the big difference is the fast rising pulses for the EMP and the IMI, which are really quite different. So in most cases, the lightning protectors will reduce the transients somewhat and can therefore be useful. But the best idea for protecting from HEMP and IEMI is to use protectors that are actually designed for the expected waveforms. George, did you want to add anything more to that?
Yeah, that's true. And I think there's some manufacturers that actually have overvoltage protection devices, transient overvoltage protection devices that are designed to handle the EMP and the lightning.
Yes, yeah, I think that's correct. Although I think we've found, and we discussed it just a few moments ago, that the best approach for signal level, signal type conductors is to use fiber connections and deal mainly with a power line, which is the issue we cannot avoid.
Right. Now for antennas, it's a little different. There you might be able to get away with a single device that does both. But yeah, for data lines, you absolutely want to go use fiber everywhere.
Great.
Yeah,
yes,
I do have one more thing to add. Building on the speed of the HEMP IEMI, that's why the MOV devices are used in conjunction with the inductive input filters. It's important that the incoming signal see that inductor and gives the MOV a time to fire.
Good. Very good. Rafiq, are you back? I guess
I'm still on my laptop.
Working. Okay, so, sorry about that.
I've been listening, and I agree with most of all of the suggestions. And yes, the inductor input inductor helps. Also, the MOV devices that are readily available from manufacturers. Great.
Okay, thank you, Rafiq. The next question we have is, what is the role of standards in your approach to HEMP and IEMI hardening? And I'd like to start that one off because I've been working a long time with the International Electrotechnical Commission out of Geneva, the IEC, and over the last 25 years we have developed approximately 20 standards and publications dealing specifically with the high altitude EMP and intentional EMI threats, coupling, and protection is the most important part. So now there are voluntary international standards available to help you understand the transient levels, to design surge arresters and filters to satisfy them, and to give protection and test methods and how to test the protection. So it's a very complete set of information. Further, the IEEE is in the process of publishing a document on protection of commercial equipment to IMI, and also SIGRE, the high voltage power people, are looking at protecting substations electronics from intentional EMI, because the substation electronics control the power flow in and out of every substation. Does anyone else like to make any comments about? Oh, excuse me, and I have forgotten the earliest standard in this area, the MIL standard 188-125, which Rafiq mentioned, which is designed to protect time urgent C4I facilities, communication facilities, against the high altitude EMP. That was one of the first standards of its kind. Do any of the other panelists like to make any comments?
Bill, this is George. There's a Corps of Engineer Tech Manual 5-690, which it has done, I think, a pretty good job of integrating EMP and lightning and EMI requirements into a single book. It maybe doesn't go into as much depth on each one of them as other standards, but I found it to be very useful in trying to protect facilities against multiple effects simultaneously.
Is that a fairly new document, or
no? It's been around, I think, maybe 10 years, something like that. But it's
okay, and it's
5-690, yeah. And
okay.
It goes into a lot of detail on different kinds of grounds for communication facilities and data centers, which is helpful. And then the other one I would mention is Mill Standard 464, which is helpful for well, what people call EQ, the general electromagnetic interference problems. And that's more at the box level.
Okay. Any other comments, Mike or Rafiq?
Yes, Bill, I'd like to just add on mill, absent any other documents that are readily available, most people tend to default to the mill standard 188, 125. The problem with that is that it is for the C4I facilities, and it may be just a bit overkill for non-military, non-critical facilities.
Yeah, on that point, I'd like to mention that the IEC is updating one of their standards, IEC 61004-24, and it will harmonize with the mill standard, but it will also include other levels of testing that can be done in the laboratory to check out the filters before they're installed, and that'll provide alternatives for the critical infrastructures.
Could you mention the number again, Bill?
It's 61004-24. It's in the final voting phase. It's an amendment that interestingly was requested by the Korean National Committee, South Korea, because they are looking at protection, and they felt that the idea of being required to do on-site testing of facilities was not compatible with the way we normally deal with EMC compatibility, which is we design protected devices, we test them in the lab, and we use quality control to ensure that they're up to date. And this removes a disadvantage for widespread application in the commercial field. Okay.
Thank you.
And I guess the last point that we have, and we're coming to the end of our time, what costs do you think are reasonable in protecting facilities from high-altitude EMP and or intentional EMI? And I would start off here with Mike.
Yes, Bill, thank you. Our experience shows that if we're talking about a brand new facility, a greenfield facility, it would add approximately 5 to 7% of the overall cost of the facility. That's inclusive of all of the equipment that's scheduled to go into the facility. If you're looking at construction costs by itself, it would be about a 20% adder into the base construction cost of a facility. Retrofitting, on the other hand, is a really whole different matter, and retrofitting can run quite easily 30 to 40% of the cost of the construction of the facility, just because of the complication of getting in there and redoing systems.
Okay. George, do you have any comment or experience from the government side? Yeah,
it's a DoD experience, where most of my career has been. Our experience is 2 to 6% again for a greenfield situation where you design you get the EMP protection in the initial design. But in general, the cost should be less than or equal to the cost of the expected losses. And with EMP, because of the just the ubiquitous effects, the expected losses can be very, very high. especially when you consider also the cascading effects. If the electric power grid goes down, you're talking, just huge multiplication factors of all the other things that will be lost as well. So the EMP protection, people need to be judicious and recognize what the extent of the losses and take that into account when deciding whether the cost is worth the investment. So that's a thought.
Okay, Rafiq, are you still on?
Yes, I'm still here.
Yes, I just want to say, do you have any comments about cost issues for protection of facilities?
Not on facilities, but I understand the retrofitting cost is it is very high. So moving forward, I guess that what to look for are the new buildings, which need to be prepared and also ready for any EMP tax, if any.
Yes, I was just going to comment, and certainly all of us, I think, agree with this idea of retrofitting being much more expensive, and the idea that as companies are expanding or building new facilities, maybe only to include new electronics in the system in their building, the idea of rebuilding a new facility over time, I believe, is a good way to solve this problem. Of course, the threat could occur at any time, but I think it's reasonable to look at saving money and trying to build new facilities with the proper hardening, because the cost, as one gentleman said, that it's in the cost overrun of building a new building when you're down to the 2 to 6% level. Let's see, we have a few more minutes, 3 minutes, I believe. Would anybody else like to add anything to our discussion this morning?
Yeah, Bill, this is George.
Yes.
I would also mention, in terms of the costs, I've seen some cases where a facility that needs to be retrofitted had just a very small complement of electronics, and if you can put your electronics, isolate them into a small volume, then you might be able to get away with just building not enclosing the entire facility in a shield, but just to have even something as small as a shielded cabinet to protect to retrofit the facility.
That's a very good point. We were, I think, generalizing, or some of us were on a large facility. But yeah, I think your point is very well taken. That if you have a very small amount of really critical electronics, you could preserve them in a shielded cabinet or even a shielded room. Right. Of course, one of the things you do have to worry about in addition is your backup power and air conditioning system. And I know there's been even some work thought about in terms of using containerized approaches for maybe adding or putting critical equipment next to the facility where that container contains everything that is really critical. See, Mike, I think you have some experience with that.
Yes, that is something that is being used now, actually. These containers, they take on the appearance of shipping containers, but they're much more sophisticated than that. But they contain backup generators, and they also are building them that contain water, cold water plants, chillers, and pumps and other devices, and you would simply pipe them into the building and connect them to a shielded volume. To expand on what George said a little bit, and you're absolutely correct, George, you would look at your equipment and perhaps put a small enclosure in, or a series of small enclosures. I'm looking at a facility now where I'm probably going to be looking at 10 or 12 individual little enclosures that will be interconnected for a retrofit, much more cost effective than trying to encapsulate the entire volume.
Okay, well, Mike, thank you very much. We're a little short on time, so I think this is it for the roundtable. I really appreciate all our panelists, and I hope our listeners have found some value in this. And we want to thank the folks at ITEM for their support in this.
Thanks, Bill, and thank you, everybody. It was a very lively discussion. We appreciate all of your expertise. We'd like to announce EMC Live 2015 will take place April 28th to 30th. Attendees, if you have any more questions, if we didn't answer, please send us an email at info@emclive2014.com. A recording of this webinar will be available on our website shortly. We will also send a link. Thank you for attending.
Okay, goodbye.
Bye now.